In this video, I want to find derivative formulas for my other inverse trig functions. And at the end of the video, I want to have this board filled in where I have derivatives for the inverse secant, inverse cosecant, and inverse cotangent of u, thinking about the chain rule. But to start, let's just find the derivative of inverse secant of x, and then we can finish out this part by writing down a formula here in terms of a function u using the chain rule. So we'll start off just by thinking about inverse secant and using the same approach we've used in the past few examples, where we rewrite our inverse function in terms of the trig function. So secant of y is equal to x. Just rewriting my trig function, and I have the domain and range written here just in case they're helpful later on. So let's take a derivative using implicit differentiation. The derivative of secant y is secant y tangent y times y prime. The derivative of x is 1, and that lets me write down that y prime is 1 over secant y tangent y. Secant of y is equal to x. And now I just need to rewrite tangent of y in terms of the variable x, and I'm going to do that by thinking about a Pythagorean identity. I know that tangent squared of y plus 1 is always secant squared of y. And so what I can do now is rewrite this in terms of tangent. Solve for tangent. And I end up with tangent of y equals plus or minus the square root of secant squared minus 1. And I could go on and rewrite that as plus or minus x squared minus 1. In the videos you watched for inverse sine and inverse cosine, you were able to ignore this plus or minus because of the quadrants we were dealing with. We can't ignore it here because my angle might be in the first or second quadrant. So tangent is positive in the first quadrant and negative in the second quadrant. So we're going to have to use that plus or minus. So right now it looks like my formula is y prime is equal to 1 over x times plus or minus the square root of x squared minus 1. Well, I don't really want that plus or minus in there. I don't want to have to think every time about this problem and think to myself, well, is it supposed to be the plus or the minus? So let's see if we can figure out what's going on here. So this statement here is really a tangent of y, and I'm going to use that to my advantage. The x value could be here or here, right? It could be minus in the interval minus infinity to minus 1, or in the interval from 1 to infinity. It could be negative, or it could be positive. The negative angles, when I plug them in, will give me these angles back for y. Plug in a negative value to inverse secant, and I have to get an angle in the second quadrant where secant's negative. So plug in a negative value here, and I get a second quadrant angle. Well, that means that x and tangent of y are both negative, meaning this product on the bottom is positive. Well, thinking about the other side, when x is positive, I get an angle in the first quadrant where tangent's positive, meaning this product is still positive, a positive times a positive. So what I realize is this product on the bottom is always supposed to be positive. Well, the square root function itself is always positive, and so now all I have to do is make the part out here always positive with an absolute value symbol. And here I have the derivative for inverse secant of x. Now I can come back to my original statement and write down the formula I wanted for the derivative of the inverse secant of u, that it's 1 over the absolute value of u times the square root of u squared minus 1 times du dx. I can use the same method to find the derivative of inverse cosecant, and I actually think that's a good exercise for you to do. So I'm going to write my answer down here. It's minus 1 over the absolute value of u times the square root of u squared minus 1. This conforms nicely to a pattern we've seen with our inverse trig functions and their derivatives so far, that I get 1 and then the cofunction's derivative is the same formula but negative. You should try to derive it, and of course if I was just taking the derivative of the inverse cosecant of x, I get that formula, but without the du dx on the end, so minus 1 over the absolute value of the square root of x squared minus 1. That just leaves us one more formula to derive. Let's do that one together now.